A warm welcome to this session of Electrician Trade. In this session, we will learn about identify various parts of relay and ascertain the operation. At the end of this session, you will be able to identify the external controls and parts of an electromagnetic relay. Identify the internal parts of a single pole overcurrent relay. Ascertain the operation of the relay. Electrician toolkit and equipments required. Electrician toolkit, multimeter, electromagnetic relay, 12 volts DC, single pole overcurrent per earth fault relay with instruction manual. Safety precautions. Once the relay is stripped, the flag will indicate a red line, and once it is stripped off, it needs manual resetting by operation of the lever. Do not allow any dust or tiny particles to enter inside the relay. Dust will deposit in the pinion and affect the disc movement. Do not touch or try to operate any projected parts inside the relay. Multimeter. Caution: while using multimeter, select proper mode of selector switch for voltage, current and resistance, and also choose proper range. Never use cable of small size for relay connection, otherwise a tripping fault may occur. Let the relay be cooled for about 10 minutes after each test. Connect the relay parts carefully. Identify the external controls and parts of an electromagnetic relay. Time multiplier setting. The multiplier determines the time delay period of the relay's operation in relation to the nominal operating time to select the desired time setting feature. It is typically represented as a numerical value or a dial setting. Trip flag. It is a signal or indication that the relay has tripped or been activated. It is often used to alert operators or monitoring systems about the status of the relay, particularly when it has detected a fault or abnormal condition in an electrical circuit. Aluminium rotating disc. The disc spindle carries a moving contact which bridges two fixed contacts when the disc has rotated through a preset angle. The angle can be set to any value between 0 degrees and 360 degrees and thereby giving desired time setting. Percentage fault quantity time reference dial. Tap setting plug. The tapping are connected to a plug setting bridge by which the number of turns in use can be adjusted, thereby giving the desired current setting. The plug bridge is usually arranged to give 7 sections of tappings to give over current range from 50% to 200% in steps of 25%. Input fault quantity. It expresses load current. Contact plug terminals. These are trip contact circuit terminals. Note down the tap setting of current ranges in the table. Note down in table the indications displayed in the dial, multiplier along with percentage of fault current and trip timing. Locate the tripping flag indicator resetting level provided in front panel. Once the relay is tripped, the flag will indicate a red line. Once it is tripped, it needs manual resetting by operating the lever. When the tap setting is set at 0.25 amperes and PSM is set at 3, the multiplier of fault current is 7.5 amperes and the time in seconds is at 18. Will trip? See the calculation. Similarly, when the PSM is 4, the fault current is 10 amperes and the time in seconds is at 10.5. Will trip? Similarly, when the PSM is set at 6, the multiplier of fault current is 15 amperes and time in seconds is at 8.5 will trip. Identify the internal parts of a single pole overcurrent relay. Loose the 4 knobs locating on the corner of the relay and remove the front cover of the relay. Keep the front cover and knobs at the safe place. Identify the aluminium disc fitted in the bottom of the spindle and time multiplier setting disc fitted on the top of the spindle of the relay. Locate the divisions marked on the time multiplier setting disc which is used for time setting and identify the spiral spring mounted on the top of the spindle which is used for bringing back the disc top to its original position after tripping. Identify moving contact fitted with the spindle on the top of the disc which is used to enable the tripping circuit and 2 terminal contact points which are used to switch to trip circuit. Record the readings. Assemble front panel of the relay. Internal parts and functions of a single pole overcurrent relay. Aluminium disc. The disc spindle carries a moving contact which bridges 2 fixed contacts when the disc has rotated through a preset angle. The angle can be set to any value between 0 degrees and 360 degrees and thereby giving desired time setting. Upper electromagnet. The upper electromagnet has 2 windings. One of these primary and is connected to the secondary of the current transformer. Secondary winding. Secondary winding is connected to the primary winding line. Lower electromagnet. Below the aluminium disc. Plug bridge. The tappings are connected to a plug setting bridge by which the number of turns in use can be adjusted. Primary winding. These are the part of pickup current coils. Trip circuit. At these terminals, tripping circuitry will be connected. Ascertain the operation of the relay. Connect the electromagnetic relay as shown in the figure to the circuit which is to be on or off automatically. Connect the circuit to the power supply and increase the supply gradually. As the current flowing in the circuit reaches the rated value of the circuit, the electromagnet of the relay excites completely. Then, the electromagnet attracts the iron core so that the NO or NC contact switch on or off the external circuit connected to it. Read and record the tripping current of the relay. Reduce the supply gradually to 0 and disconnect the power. Note: at rated current of 200 milliamperes, excited the relay, while decreasing the voltage to 9 volts or current to 120 milliamperes, insufficient of the coil current, the relay coil makes chattering. So, it is not fully stable or unstable condition. Recap. In this session, we have learned the external controls and parts of an electromagnetic relay, the internal parts of a single pole overcurrent relay. Ascertain the operation of the relay. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.